Okay, in the last chapter, chapter 14 for the semester. Here we go. So this chapter we have 3 learning outcomes. The first learning outcome is calculate dosage by body weight, and then convert weights between pounds and kilograms, and calculate individual and daily dosages. This won't be a crazy chapter. As a matter of fact, we'll go through this really quickly. We'll get it done today. Because what's going to be happening, it's very similar to what you've been doing already. More dimensional analysis, more ratios. It's pretty well the same thing as we've seen all semester. So the calculations won't be crazy, and it's just getting used to the type of questions you can expect to see. So moving right into it, we'll have a quick look. So first thing is going to be converting pounds to kilograms. So as you can see here, what they've done first, they set it up as a ratio, and that's fine. You can still use ratios, but I prefer to use dimensional analysis, as you all know. So we want to set up a ratio. First thing you need to know is that in 1 kilogram, there are 2.2 pounds. That's our equivalent statement. So we would write it like this: 1 kg is equal to 2.2 pounds. And then we set up a ratio. We put pounds in the bottom, kilograms on top. The question that they give us here, they're converting 32 pounds to kilograms. Because it's 32 pounds, we know pounds go on the bottom. Then we cross multiply. So it's this number times this number. Using the shortcut, this is going to be our x value right here. And we see it's going to be 1 kilogram times 32, which is 32, divided by 2.2. You see right here. Rounding off to the nearest hundred gives us 14.55 kilograms. That's the way we do it, using ratio and proportion. I like to use it to dimensional analysis, like this one here. But even when they do it using their dimensional analysis, they don't set it up like I like to see it. I prefer to use this one here. We always say that 1 kilogram equals 2.2 pounds. So for me, I like to start out with my pounds, 32 pounds. Then I take this here, as you know, and I set it up so that pounds will cancel. So 1 kg is on the top, 2.2 pounds on the bottom. You can see it looks the same as what they have done over here, so nothing new here. But then the thing about that is pounds will cancel, and I'm left with 32 divided by 2.2. I get the same answer they get down here of 14.55. See how they cancel the pounds down here. And you notice that this piece right here looks exactly the same as up here. But I like my way better. Just me. Alright, let's try a couple of examples of those. 14 pounds. Let's try the first one using ratio and proportion. First thing we know is that 1 kilogram is equal to 2.2 pounds. If I want weight in kilograms, let's have a look. It's going to be 1 kg over 2.2. If I'm putting pounds in the bottom, I have to put pounds in the bottom over here. So my x is going to be on the top. On the bottom is going to be 14 pounds. And I'm simply going to cross multiply using the shortcut method. I'm going to take this one, times it by that one. So it's going to look like this: 1 kg multiplied by 14 pounds divided by 2.2 equals x. The nice thing about doing it this way, you'll see right away that the pounds will cancel. My answer is definitely left in kilograms. So I have 14. Keeping my units. Divided by 2.2 equals x. And using my calculator, yay, close by, we'll turn on. Battery's dead again. Oh, there we go. We're back. Same joke. Never gets old. I cracked myself up. 14 divided by 2.2 equals, running out to the nearest hundredth, we get 6.36 kilograms equal to x. Alright, let's try another one. 55. This time we're going to do this one using dimensional analysis. We have 55 pounds. First of all, we have 1 kilogram equal to 2.2 pounds. This also works great. We're buying stuff in the superstore. You can convert kilograms to pounds pretty easy. You know, you need to just multiply or divide by 2, give you a close estimate. So we have 55 pounds. Using dimensional analysis, we want pounds to cancel. So set up our ratio here, 1 kilogram on top, and 2.2 pounds on the bottom. You see that pounds will cancel. And I'm basically looking at 55 divided by 2.2. So on my calculator, excuse me, 55 divided by 2.2. That equals 25 kilograms. Ta-da! And we're done. So nothing really new here. The only thing that's probably new is the units. We're using exclusively pounds and kilograms. Other than that, we've seen dimensional analysis before. We've seen ratios before. So the calculations should be very similar to everything you've learned so far this semester. Not a problem. Now, converting pounds to ounces. This is, again, not a really big deal, because all we need to know right here is this piece right here. £1 and 16 ounces. So if we see 14 pounds, 4 ounces, that's actually 14 and 4 out of 16. They reduced it to 1/4, now 14.25. So whatever we see at the back here, 10, basically means 10 out of 16. Then we convert it to a decimal. Once we have it in the decimal format, we can convert it easily into kilograms. Yeah. So convert it into kilograms. Sorry, convert it into decimal and then into kilograms. So first of all, looking at it converting into a decimal, we have 14.8. Sorry, not 0.8. Sorry, 14 pounds. Not cooperating. 14 pounds. And back in the old day, LBS is the symbol for pounds. And because pounds is just too long to write out, of course, right? And 8 ounces, which actually the symbol is OZ. So we know that 1 pound equals 16 ounces. All we gotta do is take the 8 ounces, divide by 16. We see that it's 1/2. So the answer is 14.5 pounds. Oops. Convert that into kilograms. Not too bad. All we gotta do is remember that 1 kilogram is equal to 2.2 pounds. So 1 kilogram on top, 2.2 on the bottom. So essentially we're dividing by 2.2. In the calculator we go 14.5 divided by 2.2, which gives us 16.59. Sorry, 6.59. My bad. 6.59. Rounding out to the nearest hundreds. And pounds would cancel. That'll be in kilograms. Awesome. Let's try one more. £22, 5 ounces. Okay, so we have 22 pounds, 5 ounces. We have 5 ounces over 16. This is going to give us our decimal. So 5 divided by 16. We're rounding to the nearest hundredth. So we have 0.31. That way. So we have 22.31 pounds. Another 1 kilogram. Oops. It's 2.2 pounds. So we take our 22.31 pounds. Same as before. You can still use ratio proportion for this, but I like dimensional analysis best. Multiply by 1 kg over 2.2. So we're dividing it by 2.2 again. So I have, I'm going to add 22 to this. Take that number, divide it by 2.2, and I get 10.14. 10.14 kilograms. Done. I'm going to delete this slide. I meant to delete it already, but I'm going to delete it right now. So the final part of this is calculating dosage. And it's the same thing essentially initially, but get more involved because it's a dosage calculation. So example right here, nurse received medication for a child, 40 milligrams per kilogram into 4 doses for 10 days, not to exceed 2 grams per day. 2 grams per day, keep in mind, 2 grams per day is 2,000 milligrams. That kind of gets you out there off track because they change the units on you. So they give us 34 pounds, 6 ounces. First thing we do is convert 6 ounces into decimal. Then we convert it into kilograms. You can use a ratio, or you can use dimensional analysis, whatever you want to do. So it turns out to be 15.63 kilograms. So 40 milligrams per kilogram. If we have 15.36 kilograms, and it's 40 milligrams for each one, we just multiply it, and our daily dose turns out to be 625.2 milligrams. And divided by 4, because it's 4 times a day, divided by 4, and we can find the individual daily dose of 156.3. Not a problem. If you do another question, same question, basically, except we use dimensional analysis, but it works out to be the same. You can see the first thing they did is convert 6 ounces into grams, into decimal, at the bottom of 16, same as always. With the same number, 34.38. It's up to dimensional analysis. I would do a little differently. I would say 34.38 multiplied by 1 kilogram over 2.2. So see how I would do it. I'll basically write this piece here backwards, going in this direction, but it's fine. And again, there's no big deal here because we're used to dimensional analysis now. We're used to ratio and proportion. Once we get this set up, it turns out to be 15.63 kilograms. And again, just taking the number and multiplied by 40. That comes out to our dosage, daily dosage. And divided by 4 gives this our individual dosage. Not too bad. Let's try a few questions on our own. So question number 1 here says 8 pounds 10 ounces. Recommended dosage from drug labels 15 milligrams per kilogram over 24 hours. So basically this is 1 day, 1 daily dose, 15 milligrams per kilogram. So first thing we do is convert this into kilograms. So we have to convert 10 ounces, 10 ounces, 16 ounces. Let's do it the long way, just for practice. We know that 1 pound has 16 ounces. Let's not do it that way. I'll make it more confusing. Let's just keep it simple. Say it's 10 ounces over 16 ounces. That's going to give us our decimal place. So we have 10 divided by 16. That gives us 0.625 pounds. Actually, yeah, I'm going to do these dimensional analysis. What the hell? We got to handle that by now. So I'm backing up. So we know that 1 pound equals 16 ounces. So we have 10 ounces multiplied by 1 pound for 16 ounces. So you see it works the same way. Works the same way. Still got our 10 ounces. 10 over 16. It works out to be 0.625. Running off to 100ths, 0.63. So what we have 8 pounds, or 8.63 pounds. Convert to kilograms, we know that 1 kg equals 2.2 pounds. So we have 8.63 pounds multiplied by 1 kilogram. We're converting into kilograms because our dosage is given to us in kilograms. 2.2 on the bottom. And pounds cancel. So we have 8.63 divided by 2.2. That gives us 3.92 kilograms. Looking back at our question, what's the weight in kilograms? That's done right here. Weight in kilograms is 3.92 kilograms. We get 15 milligrams per kilogram. So we'll take our 15 milligrams. So we have our and we get 3.92 times 15, 58.84. And that would be our daily dose. 15 milligrams per kilogram. We have 3.92 kilograms, 15 milligrams for each one. Daily dose. Alright, hope that seems clear enough. It's not that bad. Just converting into kilograms, multiplying by a number of milligrams per kilogram. If I were to do this with the units involved, let me just show you before I move on. This would be, I just went back, makes me pace myself. Just showing the units calculation, just thought of that. We had 3.92. That's kilograms. 50 milligrams per kilogram. And you would see that kilograms would cancel. And in fact, we would be left with milligrams. Just want to run back to that just to show you the cancellation units. Let's try another question. This one is 40 pounds, 6 ounces, 300 milligrams, not to exceed 12 milligrams per day. Recommended dosage is 65 milligrams per kilogram over 24 hours. So we have 65 milligrams per kilogram. Okay, first thing I do is convert pounds into kilograms. So we have 6, I'll use the color. No, I'll pick able colors. 6 ounces multiplied by 1 pound over 16 ounces equals, you know that our ounces will cancel. And I have 6 divided by 16, and it's 0.375. Which equals 0.38 pounds. So we have 40, total would be 40.38 pounds. Converting pounds to kilograms, we go 40.38 pounds multiplied by 1 kilogram over 2.2 pounds. So once again, it's the same calculation over and over. Pounds will cancel. And I have 40.38 divided by 2.2 equals 18.35. That would be kilograms. And we get 65 milligrams per kilogram. So we have 18.35 kilograms. It's 65, yep. Multiplied by 65 milligrams per kilogram. I'm writing it out this way so you see the cancellation of units. Gone, gone. We have that number times 65. That gives us 1,193.05 milligrams. Not to exceed 12 milligrams, so we are in a good situation because we only have 1193 milligrams. It's all good. Alright, one final question. Maybe two. Maybe two questions. Physician orders 1.5 milligrams per kilogram over 24 hours. Why didn't the 3 daily doses? The client's weight is 78 pounds. What's the weight in kilograms? So this is a little bit simpler. It's no dismal here. We have 78 pounds multiplied by 1 kg over 2.2 pounds. We'll see the pounds cancel. Once again, I'm dividing 78 divided by 2.2 equals 35.45 kg. And we have 1.5 milligrams per kilogram. So we take our 35.45 kg, multiply it by 1.5 milligrams per kilogram. Notice how kilograms will cancel. So it's 50 milligrams per kilogram of 24 hours in the 3 doses. So multiplying those two numbers there times 1.5, that gives us 53.18 milligrams. That will be our daily dose. Because it's 1.5 milligrams per kilogram for all the kilograms. But that's to be administered 3 times a day. So we have 53.18 divided by 3 doses per day. It's the easiest way to do it. It's kind of using common sense. 17.73 milligrams per dose. Sounds good. Doing pretty good. Not a problem. Let's try one more final question. That'll be it for the entire chapter. This one here is using the label. So it says a pediatrician has ordered 5 milligrams per kilogram for a child weighing 54 pounds. How many tablets will be administered? First thing we should notice is that there's 100 tablets. Each tablet is 400 milligrams per tablet. So, first thing we got to do is convert 54 pounds into kilograms, because again it's milligrams per kilogram. So it's going to be 54 pounds multiplied by, see, it's the same calculation over and over, just converting into kilograms. 2.2 pounds. So it's the same calculation. We just take our 54 divided by 2.2, and we get 24.55 kilograms, because pounds will cancel. And now it's 5 milligrams per kilogram. So it looks like this. We have 24.55 kg multiplied by 5 milligrams per kilogram. You see, it's easy to see now how the kilograms cancel. And it's going to be that number here multiplied by 5. It's going to be 122.73 milligrams. This question says 5 milligrams per kilogram. Child weighs 54 pounds. How many tablets will be administered to the child? Well, we have 24.5 kilograms, 5 milligrams, works out to this number here, tablets come in 400 milligrams per tablet. Let's take that number here. So we're using dimensional analysis again, 122.73 milligrams multiplied by 1 tablet over 400. And you see it's the same thing with dimensional analysis. Milligrams always cancel out. And we have that number there divided by 400, which gives us 0.3. .31 tablets. So we have a problem here. 0.3 actually boils down to 1/3 of a tablet. And we do not serve tablets. Tablets not done in 1/3 because we have no way of regulating that. So in this case, it's sort of a trick question. And the appropriate answer will be call the physician for clarification on the dosage. And that's it. That summarizes the whole chapter. And basically, if you have any questions, don't hesitate to email. I'll be opening up all the assignments. And I'll send you an email shortly. Thanks for attending. Have a great day. Bye.